The MCAT always asks this physics question.
Question 2. If the second floor and the top floor of a building are separated by a distance of 100 meters, what is the approximate difference between the air pressures of the two levels? And they give us air density to be 1.2 kilograms per meter cubed and gravitational acceleration to be 10 meters per second squared. So we need to recognize that this question is actually asking us about fluids effectively, right? Because air and gases are also fluids, all right? So if we were to draw this in a way that makes sense for fluids, let's say it's like a tube and there's a fluid in it. In this case, of course, it's a gas, but we could pretend that it's filling like this tube. And we're saying that the top of it is going to be 100 meters high and the bottom is 0, right? Because they're asking us about from the second floor to the top floor, we'll just say that the top floor is like 0 meters, right? And so we have like a bunch of fluid in this container, all right? And we want to know the pressure. And so that pressure would actually be the hydrostatic pressure, right? And there's going to be a pressure down here, and then there's going to be a pressure up here, okay? And of course, the difference between the two is going to be 100 meters, right? And they're asking us for the difference. Now, the hydrostatic pressure is actually given by the density of the fluid multiplied by the acceleration due to gravity multiplied by the height. So if we were to plug in those values, right, this is going to be the density of air, which is 1.2, multiplied by 10, multiplied by 100, right? And so this is just going to be 100 times 10 is 1,000 times 1.2, okay, is going to be 1,200, and that's going to be newtons per meter squared. So D is going to be the right answer. But where is that pressure actually? Well, that pressure, okay, is going to be here, because pressure decreases with increasing height. Okay, so the 1,200 newtons per meter, if we set this to be 0 and this to be 100, right? We have all this fluid, this gas in this case, pressing down on us here, if we're down here with this pressure. Up here, it's going to be 0, okay, since we're relative to this 100 meters, right? Now, obviously, if this is in actuality, there's still going to be a pressure. It's just that the difference between the two is going to be 1,200 newton meters squared.